Welcome back, everyone. Today we're going to be talking about the derivatives of inverse functions. We mentioned this briefly when we were talking about taking the derivative implicitly, especially when it came to the trigonometric function of sine and cosine. I'm going to start by first writing down a couple of theorems that we will be using in this section. The first one is called continuity and differentiability of inverse functions. So, continuity and differentiability of inverse functions. And it says the following. It says, let f be a function whose domain is in an interval I, capital I, if f has an inverse function then the following two statements are true. Number one is that if the function f is continuous on its domain, then the inverse of f inverse, is also continuous on its domain. And two, if f is differentiable, remember differentiable means that the derivative exists on an interval containing c, where c is a real number. Interval containing c. And further, the derivative, when you evaluate it at c, at that real number, is not 0, then f inverse is differentiable at the point f of c, at the output value f of c. Keep in mind, and if you have a function that looks like this, let's say you have c here, then f of c will be a point up here. So this is saying that if this f function is differentiable at this point c, then the inverse function, however it may look like, will be differentiable at this point f of c. Okay. And the other theorem that will be of importance to us today is the actual rule for the derivative of an inverse function. So this is the derivative of an inverse function. And it says the following: let f be a function that is differentiable on an interval I if f has an inverse function g then g is differentiable at any value of x for which the derivative of f evaluated at the inverse of f is not equal to 0. Moreover, g prime over x is equal to 1 over the derivative of f evaluated at g of x. And this is why it's important that when you evaluate the derivative at the inverse, we get a non-zero value because we cannot divide by 0. So, first of all, let's